In section 8.2, we're looking at properties of parallelograms. This is the first type of quadrilateral we're going to look at. Remember that a quadrilateral is any four-sided polygon. Now, a parallelogram specifically is one of the most common categories of quadrilaterals. A parallelogram is a quadrilateral, four-sided figure, with both pairs of opposite sides parallel. Kind of makes sense from the name, right? Parallelogram. So both pairs of opposite sides have to be parallel. Symbol for parallelogram is a mini parallelogram here. We have parallelogram PQRS. Now it is a parallelogram if by definition both pairs of opposite sides are parallel. You notice I wrote here that line segment PQ is parallel to line segment RS. I could mark those with one arrow. And also line segment or side QR has to be parallel to line segment or side PS, and I would do two sets of arrows here to distinguish those parallel lines. That makes this a parallelogram by definition. Both pairs of opposite sides are parallel. But that's not the only property that's true about parallelograms. We actually have quite a few properties that are true. All of these are properties that are true about parallelograms. If a quadrilateral is a parallelogram, then these four things that I put dots by are true. The stars are reasoning behind why it's true. First of all, in a parallelogram, opposite sides are congruent and opposite angles are congruent. I'm going to mark those in 1 second, but I want to show you why this is true. Both of these can be proven by drawing diagonals and finding congruent triangles. For instance, if I drew in this diagonal, just knowing, remember this is a parallelogram, right? So I know that my opposite sides are parallel. That would be the given from the fact that it's a parallelogram by definition. Well, now that I have parallel opposite sides, parallel lines always give us information about angles, right? So these parallel lines make these angles alternate interior angles, and they're congruent. Then these lines are parallel, so if I use these parallel lines in the transversal, I now have a new set of alternate interior angles congruent. And finally, this side, because we're looking at the two triangles that are formed, this side is shared. Now the triangles are congruent by angle, side, angle. Okay. Now since the triangles are congruent, I know that their corresponding parts are congruent, which makes opposite sides congruent. So these two sides are congruent because they're corresponding parts in these triangles. I know these two sides are congruent because they are corresponding parts in these triangles. And I know that these opposite angles are congruent because, again, CPCTC, corresponding parts of congruent triangles are congruent. I'm going to get rid of some of this stuff, the extra stuff I don't need. These opposite angles are congruent because of that diagonal, but also these opposite angles would be congruent if I did the other diagonal, and the same thing with those congruent triangles. Okay, so parallelogram by definition had the opposite sides parallel as I marked with the arrows. We also have discovered that opposite sides are congruent. I marked one tick mark here and here, two tick marks here. Opposite sides are congruent. Opposite angles are congruent in a parallelogram. I marked those with one arc and these with two arcs. Also, we know the consecutive angles are supplementary. Consecutive angles, remember consecutive means one after another or next to each other. Why would these two angles then be supplementary? Or these two angles be supplementary? Or these two angles? Well, hey, we got parallel lines. Remember how this is a transversal between these two parallel lines, and you have two angles on the interior, or in the interior, and they are on the same side of the transversal. Those are same side or consecutive interior angles, so they must add to 180. Remember, that's the definition of supplementary. Add to 180 degrees, because you're off of parallel lines here. One's obtuse and one's acute. And lastly, the diagonals bisect each other. So I have to draw the other diagonal here in this parallelogram. Wait, what does it mean to bisect each other? Bisect means cut in half or cut into two congruent parts. Therefore, I know that this section of this diagonal is congruent to this part of this diagonal. It is cut in half by the other. And I'll do IV for 4. These two parts are also congruent. That diagonal is bisected as well. So, by definition, parallelogram has opposite sides parallel. We also find out opposite sides are congruent. We also find out opposite angles are congruent. Consecutive angles, angles next to each other, are supplementary. They have to add to 180 because of the parallel lines. And the diagonals bisect each other or cut each other in half into two congruent parts. Well, since this is all true about parallelograms, we should be able to do some problems with parallelograms and find unknown variables. I'm assuming, first of all, that these are parallelograms, by the way, so you don't see any marks, but they are parallelograms. Well, let's deal with the angles first. I have a parallelogram. I have a 72-degree angle. Now we know that opposite angles of parallelograms are congruent, so in this case, angle X, also 72 degrees. They're congruent because they're opposite from each other. They're both acute. Angle Z, on the other hand, would have to be supplementary with the angles next to each other. So really, I know that they add to 180 with angle Z. So I'm doing 180 minus 72. And angle Z must be 108 degrees, so that 108 and 72 add up to 180. And what about Y? Remember that opposite sides of parallelograms are congruent as well. So this side of y minus 8 has to be congruent or equal to 36, which means if I add 8 on both sides, y equals 44. So I've got x, y, and z for the first example here. What about in this parallelogram? Alright, notice I have a 50-degree angle, and I know that opposite angles of parallelograms are congruent. So 50 has to equal 2x. They have to be congruent or the same. Divide by 2, and x equals 25. Now angle Z is consecutive next to one after another with the 50 degree and the 50 degree here. Now we know that those consecutive angles add up to 180. They're supplementary because they're off a parallel line. So I'm doing 180 minus 50 degrees. I know that angle Z would have to be 130 degrees. And then what about Y? Well, y plus 3 is this side length, and that side length needs to be equal to the opposite side length because opposite sides are congruent in parallelograms. So y plus 3 has to equal 18, which, subtracting 3 on both sides, 18 minus 3, y would have to be 15. So there we're using some of our properties of parallelograms. Here I have a parallelogram in a coordinate plane. And I'm told the diagonals of this parallelogram PQRS intersect at point T. The diagonals intersect here. What are the coordinates of point T? Well, what do we know about the diagonals of a parallelogram? What do the diagonals do to each other? They bisect each other. So what does that mean? If the diagonals are bisecting each other, T is the what of those segments? Did you get a word from me yet? T is the midpoint of those segments. And if you remember how to find the midpoint in the coordinate plane, you're finding the middle of the x's, the middle of the y's. Thing is, you can do either diagonal. Either T is a midpoint of PR or T is a midpoint of QS. It's a midpoint of both. You can honestly pick which diagonal you want to use and find the midpoint of. I don't know, maybe I'll do QS. It really wouldn't matter. But I'm going to find the midpoint of these 2 points, so I better write the coordinates here. S is at 7, 3. Q is at 4, 6. So to find point T, I'm going to do the midpoint. I'm going to add the x's divided by 2. The x's are 4 and 7. I'm trying to find the middle of those. I'm averaging them. I'm adding divided by 2. Got to find the middle of the y's as well. The middle of 6 and 3, I would add 6 and 3 divided by 2 again to find the average or the middle. 4 plus 7, so 11 divided by 2. 6 was 3, so 9 divided by 2. Looks like T is at 11 divided by 2 would be 5.5, comma 9 divided by 2 would be 4.5. T should be the midpoint. Let's see if that looks right. 5.5, 4.5. 5.5, 4.5. Looks good. Okay, keeping in mind the diagonals bisect each other so that the point where they intersect is the midpoint of both of those diagonals. Again, I could have used points P and R and it would have turned out exactly the same. And a little bit more here with our parallelograms. We're going to find some missing lengths and angles in this parallelogram. Find NM. Okay, NM is half of this diagonal, N to M. What do you know diagonals do to each other in a parallelogram? They bisect each other, they cut each other in half. If NK was 5, That means NM also has to be 5. This diagonal was bisected, cut in half. Each of these are congruent. So what about KM? Looks like KM is the length of the entire diagonal. We have 5 and 5 for the length of diagonal. Total length would be 10 there. Alright, next, measure of angle JML. Where are we looking? Measure of angle JML. So that's this entire angle. Okay, well this is the full angle of that parallelogram. If I knew the opposite angle, they'd be the same, but I don't know this angle. Oh, but I do know a consecutive angle. Okay, these two angles, what do you know about them? Well, this whole thing is 110. This whole angle must add with 110 to give me 180. By the way, that 30 is only referencing this part of the angle. So I'm doing 180 minus 10. I know that consecutive angles need to be supplementary, add to 180 because of the parallel lines. So it looks like this angle would have to be 70 degrees for the whole thing. 70, 110 will give me the 180. And finally then, can I find measure of angle KML? KML. Okay, L's up here. Sorry. Angle KML, I am looking at this part of the angle right here. If I know this much is 30 and the whole thing was 70, this angle would have to be 40, right? 70 minus 30 giving me 40 degrees for that angle measure. Oh, one thing I haven't mentioned yet, but actually, like, these two triangles are congruent triangles as well. You have vertical angles here, opposite sides here congruent, diagonals bisected. Those triangles are congruent for a lot of reasons. Same thing with these two triangles here, also congruent by a lot of different shortcuts because of what we know about parallelograms. So keep that in mind as well. But yeah, today looking at properties of parallelograms.